Robotics, as you can imagine, don't have a lot of direct impacts on the finance space, but a lot of indirect implications. If you think about insurance, you think about interesting retail opportunities. I'm going to give a quick overview of the robotic space, some of the leading edge new breakthroughs and opportunities that we're seeing, and kind of have a story at the end. But I think I'll start with a quick story that pretty much summarizes my whole perspective on where robotics is today. So I told a couple people this yesterday. Last week on Thursday, we opened our first innovation hub, a regional innovation hub in Eindhoven, Netherlands. So as part of Singularity University's strategy to bring awareness around exponential technologies out in the world, we're empowering our alumni base to take some of this thinking to develop their own content and programming. And the first manifestation of that is in the Netherlands because of our alumni base and some interesting partnerships. So we have a physical innovation hub in Eindhoven, Netherlands, in partnership with the mayor and a bunch of other people. Queen Maxima of the Netherlands opened this innovation hub. It's pretty amazing. I mean, how many events do you have where the Queen is opening an event, right? So this is pretty exciting for us. And interestingly for me, I was in LA for another event and I couldn't make it. And so it's a great sign of disrespect to not be able to show yourself in front of a Queen. So I beamed in on a telepresence robot, right? Everyone's seen the beams. You'll get to see some more of that later. And turns out, shortly before I was supposed to interact with the Queen, security protocol in the Netherlands says the Queen cannot interact with a robot. Well, that's unfortunate. So I missed my ability to interact with her. There's some theories, because you're in a robot, you can't actually officially bow over. Maybe that was the problem. But I think it's, the camera and some other issues. Now, ironically, something else happened. We had a big ribbon cutting ceremony where we had 2 drones lifting the ribbon, and then we had other drones with scissors that were going to swoop through and cut the ribbons, and it's totally fine for the Queen to be involved with this activity. You can kind of see a lot of different themes here. There's a lot of technology moving so quickly, and a lot of archaic regulation and mindsets around what the technology is and what it's capable of. Right? And so we have a lot of work to do to upgrade our thinking and to upgrade our systems to deal with the incredibly fast pace of robotics. So a couple quick things. That the exponential pace of robotics is really being driven today by 3 key things. Moore's Law. The sensors that we have in our pockets today, it's extraordinary. The size, the cost, moving exponentially, so the capabilities that we have available are incredible. And then the way we teach robots is totally different. When I started my first robotics business now, it's 20 plus years ago, to program a robot to do the most simple of moves, you would have to write assembly code and machine language, which is really not much better than 001100, just slightly more effective. So it would take you weeks and months to program a complicated system. Today we have open source libraries of code, we have drag and drop software tools, a robotic operating system, where 8-year-old kids can program pretty complicated robots to chase the cat and throw a ball at it when you say a magic word, right? If you get the Legos Mindstorm kit, you can do exactly that this weekend. Different paradigm, right? And in the open source community, you got hundreds of thousands, actually millions, of PhD roboticists and 8-year-old kids sharing code about robotics, which means every business that wants to test any kind of a new robot prototype this weekend, you can get started. Right? You can basically take a standard platform, use open source code for parts of it, and have a proof of concept running in no time. So a very enabling piece. So I'll just suggest anything that we do physically that it has to be safe, accurate, fast, cheap, is perfect for consideration of robotics. Right? And again, robots that I'm talking about today are going to be the physical manifestations. These are the ways that computers can interact physically with the real world. Or real, whatever you want to call the real world in this crazy time. I'm not talking about bots and AI. Neil sort of showcased how that's transforming our world. I'm going to focus on the physical robots in our world. So this is what robots look like today. This is the Tesla factory in Fremont, California. Leading edge industrial scale robots that are extremely fast, extremely efficient. They're also locked in cages because they're also not very aware of their environment. So this is the typical industrial scale robot that is replacing physical tasks. These are perfect for volume tasks. Now, interestingly, the new face of manufacturing robotics looks like this. And Baxter came out now almost 3 years ago from Rethink Robotics. There's several different versions out there. Baxter is just one version of a robot that's collaborative. It's about being aware of and interacting with the environment and not being in a cage. To teach Baxter what you want it to do, you essentially show it. You walk it through the steps. If I want to assemble this clicker, I'll take the pieces out of the box, I'll assemble them, I'll put it over here in this other box, right? So you take a non-skilled manufacturing laborer and you turn them into a robotics programmer, right? This is an amazing, empowering thing. What you'll notice in these videos is that they're also pretty slow and not super accurate. So what you lose with the collaboration and adaptability is the speed and the accuracy. But that's coming quickly, and if you think about a price point starting at $20,000 US, now we're starting to get very interesting in the manufacturing space. Granted, manufacturing labor still costs about $8,000 annually in Indonesia. Right? So if you think about typical processes, we're still quite a ways out, and a typical human is going to be much faster and much more accurate than this device. But it is accelerating exponentially. Okay, the next piece is really cutting edge. So that showed you sort of where we're at in the lab with collaborative adaptable robots, but the leading edge, best-in-class robotics can probably be best shown in the DARPA Robotics Challenge. So DARPA, the Defense Advanced Research Project Agency, was pretty scared of what transpired with the Fukushima nuclear power plant disaster several years ago. If ever there was a situation where you have to go in and solve the problem, but you really don't want to send humans in, it's a nuclear fallout situation, right? So they put up a $2 million prize to develop robots that could do disaster recovery, right? So they had 8 discrete tasks. There were about 20 teams that competed, and each team had an hour to complete every one of these tasks, right? So these are pretty basic things. So this is what it looks like. Not all of the robots are humanoid. And one very big caveat here, this video is all sped up, like 10 to 20 times, because watching a robot take an hour to try to walk over these bricks is mind-numbing at best, right? However, if that's for you, there's 3 days worth of videos online. You can go and check it out. It's really a lot of fun. And also, these are pretty basic tasks that we take for granted every day. Now, these are autonomous robots that basically don't know what's going to happen when they come into the environment. They know what tasks they have to complete, and they're able to do it. No single team completed all of these tasks. And again, this was the first challenge. This is 2.5 years ago now. One very important thing also to note is there's a tether on all these robots. One, for safety, because these are multi-million-dollar robots. If they fall over and break, it's a very expensive proposition, so you want to save that. And 2, for power. One of our biggest limitations is power. You just heard from Ramez, that's getting better and better, but that's why the umbilical's there. And you notice that this robot, there's a lot of failures. Again, no single team completed all tasks. Every task was completed by a team, but no team could do all of them. Now, when I saw this, I was just floored, because I have a little research project at home that I'm working on, and it turns out I'm basically operating about this level. So I'm going to show you what that looks like. This is the Beckett bot. This is the Beckett bot about a year into research, already able to negotiate pretty complex terrain. It is able to clear debris pretty successfully. It does make probably a lot more debris than it clears, candidly. It can push and drive vehicles. It is able to navigate open doors, much to its programmer's dismay, as it runs out in the street sometimes now and scares us to death. And we have had some failures along the way, right? We've had some falls off of steep high places, had to repair with stitches, and then we reprogrammed, and we've never seen the same failure again, right? So pretty successful. Now, I love this, he's cute, I love him, but mostly because this is a great analogy for where best-in-class, general-purpose, autonomous robots out in the wild is, right? Not much better than a toddler. So you're not going to build a robot that's going to come enter into your house and do your laundry and then sweep the floors and do all these other tasks. It's way too complicated, right? However, things are changing. And the next challenge, sort of the Tier 2 challenge, last year, this is last June, now 1 year ago, another big set of prizes. There were about 20 teams that competed. This year, 3 teams completed the entire competition. Also, let me back up. There were 10 challenges, and they only had an hour to complete all 10 challenges. Right? So the first year there were 8 challenges and they had an hour to do every piece. This year they had 10 challenges and they had only an hour to do all of them. Also, this is actually the winning team, a team out of Korea. You'll also know that there's no tether. So another constraint on the challenge this year, increased the challenge dramatically, no additional power, and no safety harness. So if it falls over and breaks, it's broken, right? A lot of novel approaches. All of them are fairly humanoid in nature because going into a disaster scenario is a human-built environment. So the doorknobs are things that human grippers need to be able to open. Again, this video is sped up. You can see the timer on the side. But again, the robot's doing some pretty basic things that we would just rush in and do very quickly. But considering they weren't able to do all of these just a year before, it's a nice sign. But again, they don't know exactly how everything was laid out or how to do it. So I'm going to fast forward to the final task here. The final task was walking up some stairs, and you'll hear some sounds in the back. So this is actually a live event, and they'll pan across here. This robot is successfully walking up a few steps. That's the endeavor that it's going through. And you'll see we have like 10,000 people losing their minds, right? Of course, candidly, we killed the sound on that, actually. Candidly, most of the faculty are in that crowd, so we are part of that. But this shows this interesting connection that we're starting to have with these technologies, and we're rooting them on in new ways. Now, it was not all glory, of course, right? There's obviously a few disasters along the way. When you don't have any safety harness, things go wrong. I think we have some sound on this, if we can turn up the volume. And you notice how tense the crowd is, too. Everyone's into it. Oh, no! Okay, so fast forward 6 more months. So that was last June. In January, Boston Dynamics, which built one of the platforms that competed, the Atlas, they unveiled the next version of the Atlas platform, which is this little guy. Already a pretty remarkable improvement from that competition. This is not CGI, despite what you may think. This is a live robot navigating out in the wild, trying to get through some pretty difficult terrain. Now this is where the demo starts to take a weird turn. So obviously inventory control and moving boxes and things. But this guy is really, showcasing some of the abilities to adapt in an environment. But now, you all know that anything you put online is there forever, right? So if you're caught in a video knocking over the robots, and in 20 years from now, when the robots wake up, you really think he'd want to put on a mask or something for doing that, right? So just a caution. And when I watch this sort of recovery of this robot, it feels a little more like the Terminator to me, right? It's just a little, I don't think I want that walking around the yard outside. So I watched that, I'm like, okay, how's the BecketBot tracking? So same timeline, BecketBot going through some pretty similar complex terrain. about the same, actually. You know, a little wobbly, but pretty smooth. But here's where he really is drastically better. In terms of dealing with random contextual elements that are unknown at the time, he seamlessly and fluidly can go from object to object. Color, size, weight, really very simple for him to do, right? And this is where it's a pretty tough environment to program that level of fluidity in an unknown environment. Contextual awareness is really still the big challenge. This is another thing that I found very interesting. In a social environment where he, literally in 30 seconds, he met these kids, they taught him how to play a game tag, and he's instantly able to mimic and follow and interact with them. This is also something that's very, very difficult to program because there's so many variables and interests. I just love, he's totally into it, right? And now this is the piece that I'm certain we're going to not see from robots in a long time. The level of creativity and inventiveness. We do have some AIs doing art and other stuff, but that we're not going to see for a while. So again, best-in-class robots out in the wild, not much better than toddlers, right? I think a couple of years from now we'll see who's tracking better, the Beckett bot or the Terminator, but we'll see. So where it does get interesting, mostly for commercial applications, is when you simplify it. You're not going to build $1 million robot to try to do everything in your life. You're going to simplify that technology down to do some discrete tasks and work with the environment you have. So Panasonic has a great little exoskeleton that they just launched last year in the sort of inventory management environment. This is where you get a little extra strength, a little extra stability and safety, and you utilize all the sensors and capabilities of the humans, right? More technologies like this are coming online every day that are very powerful. And that sort of takes us to the next phase where I think on the commercial applications in stores and retail experiences, this is super exciting. So last year we had Fellow Robots here, which is one of our SU companies, where they built the Oshbot. Now they're building lots of different retail robots that are concierge level service in stores. We have the Relay. In fact, if any of you come to our 7-day program at Singularity University, our exec program, you'll stay at the Aloft Hotel, where room service is all delivered with robots today, right? Because in a known fixed environment, like a conference hall, the robot knows the map, the layout of the space, and it knows what it's going to interact with. There are not an infinite number of variables that the robot has to deal with. So contextually, it can be very smooth and consistent. Right? This is where things are very exciting. Also, if you come to Palo Alto, the Stanford shopping mall security looks like the K5. Literally, the K5 is a security force at the Stanford shopping mall in Palo Alto today. So this is pretty exciting. Now, if you overlay this with some other technology around facial expression analysis, or Beyond Verbal is another SU company where they can do vocal analysis and understand your physical emotions. Right? Robots now understand your emotional state and can act accordingly. They don't quite have emotions themselves the way that we think of them, but they absolutely understand our emotions now, or they can. And so a whole new line of interesting consumer-level products are out on the market and being introduced this year. The one I like the most is Pepper. This was introduced in Japan last year, specifically just for the Japanese market, targeting the elderly. Has anyone seen the movie Robot and Frank? It's probably one of my most highly recommended robotics films of all time. It's about an elderly gentleman who is falling into depression. He's long since retired. His son is thousands of miles away, so his son buys him a robot, right, to be his companion. And basically the robot tries to get him to get back into fitness, to eat his broccoli, and it's so annoying that the guy doesn't want to deal with it. Then the robot realizes, oh, he's got some old hobbies that he hasn't been doing before. Turns out he was a jewel thief. That was his hobby. So you can see where the robot now is helping him do sort of nefarious things, which is a fun part of the story. But the reality, and this movie came out 2 years ago, and here we are today with Pepper being launched in Japan as a companion for the elderly. And this is what Pepper does.
香織さん、おかえりなさい。今日はいい日でしたか？
うるさい。ほっといて。
ママ。わかりました。 れない？ばー。笑顔になりましたね。
ありがとう、ペッパ。
あ、マサトさんからペパメですよ。今日はごめんなさい。僕が悪かったです。
よかった。
よかったのに泣くんですか？
いいの。
女心はよくわからないですね。
All right, so I'm fairly certain that robot does not cheer me up in that situation. But there may be a demographic that it would, right? Cognitive impaired, elderly, folks who don't have connections and are very lonely, that actually may play a role and already is being tested. So we're going to see more and more of this. Also, for safety provisions and just calling a friend, that's an amazing capability to have. But more importantly, if you think of a robot as an information platform that's aware of its environment and is tracking everything that's going and potentially making its own correlations about what's happening, and back to its sort of values of what it's trying to provide, some really exciting things happen. So some research has come out over the last couple of years that suggests, specifically targeting elderly again, if your behavior changes dramatically, so for example, if I have tea at 2 p.m. every afternoon, and then all of a sudden I start taking 2 at 3 or 4 p.m., it's a very clear sign of a declination of health or a change in health status, right? But you wouldn't, if that was you, you wouldn't really recognize that, you've changed your behavior or your habits, but a robot would. Because it's tracking, and it just notices, you have tea every day at 2 p.m., and that's a pattern, right? So these technologies, not just robots, but the IoT, right? If all the devices and things around us are now information platforms that are aware of their environment, what kind of new correlations and interesting, valuable propositions can they provide to us? And when you think about health, that's one of the most exciting ones for us, right? So if you think about all the crazy technologies that are coming online that potentially personally and our businesses have access to that information, what kind of value can we see and create? Now, the big thing that I wanted to just sort of hit on just very briefly, there's a lot of research, a lot of concern about the future of jobs, largely because of robots. Physical robots aren't going to sort of worry any of us in this room, but the AI ones should, to a large degree. And the research from Oxford, now this is 2013, says 47% of jobs face high risk of being replaced by automation, in the US specifically, but this is worldwide now we're talking about. And the rest of the research that's come online is a little bit more conflicted. A Forrester report last year came out suggesting that there's a lot of jobs that are going away, 22 to almost 23 million, but there's a lot of new jobs that are going to be created. And we know that's going to happen. There's a tremendous number of new jobs that we can't even foresee yet. Robot technician, I think, is going to be one big one, right? But more importantly, almost all jobs, they're suggesting 25% of all jobs are going to be transformed because of automation and robotics. Meaning your role will start to integrate automation and robotics in totally new ways, which means your role is going to change pretty dramatically as well. Now, if you see how this plays out on an exponential curve, that's just going to keep happening more and more and more and more. To what inevitable conclusion? Well, in my theory, the inevitable conclusion is technology, robotics, automation will provide all the basics for us. Every physical task and activity, whether it be food, transportation, you name it, will be provided through technology and automation. No longer do we have to use our limited physical capacity to do any physical tasks. Automation will provide it for us. I'm going to suggest in a 20-year timeline, the price performance of robotics, physical robotics, will be such that almost every physical task will be an opportunity for robotics. Every physical task worldwide, right? So, are we prepared for that even remotely? No, not even possible. Like, we still live in a world where our economic system is very much dependent on everyone having a job. We ran some forums where I invited some administrative folks in the government and the sort of labor departments to come to a forum where we talk about an inevitable future of robotics where maybe everyone doesn't have a job, and maybe everyone doesn't need a job. And the response was, you know, I don't think I can show my face at any event that talks about a future where everyone doesn't have a job because it's political suicide. Now that frightened me, because if our politicians can't even entertain a different version of the future, how are we going to get there? Right? So I'm very excited about experiments like what just happened in Switzerland. I don't know if you know about it, but the universal basic income was just voted on and rejected. At least it was on the ballot as one potential version of an economic system to allow for a long-term future where technology is going to play a much, much bigger role. This is one experiment. We need to be running thousands and thousands of experiments around the world to figure out a new economic system. But I think most importantly is the mindset required is one where if you just read the news and you just watch the movies, you are expecting the dystopian zombie apocalypse to happen, right? It's time to start talking about a different future, one of abundance, where technology can provide the basics, but our mindset and our systems need to shift pretty radically to provide that. So last, how many of you have kids? Okay, kids age 5 to 105, I highly, highly, highly recommend you get Lego's Mindstorms. It's a great way to start with robotics because we need to usher in a new way of thinking around robotics and programming, and there's a lot of tremendous resources to do so. Thank you very much.